of things today, right? And tomorrow we're going to meet up again, and then we're going to cover a lot of other things. What did we cover in the last class? And tomorrow we're going to meet up again, and then we're going to cover. So, what did we cover in the last class when we met? We spoke about we spoke about introduction to cloud, right? We spoke about introduction to cloud, if you guys can remember. And we said that cloud just simply means someone is giving you access to a service over the internet, and you're just simply making use of that service, and you're paying for what you use. That's pretty much what we spoke about, regarding cloud, right? One thing that we didn't we covered the cloud service delivery models, spoke about infrastructure as a service, platform as a service, software as a service. Now, apart from that, one thing I'd like to tell you guys about is I'd like to tell you guys about public cloud. I'd like to tell you guys about private cloud. Okay, I'd like to tell you guys about hybrid cloud, what that actually means. Okay, so I'd like to talk to you guys about public cloud. I'd like to talk to you guys about private cloud. I'd like to talk to you guys about hybrid cloud. What does that actually mean? Okay, so we'll just give ourselves 15 minutes. You should be done with this, so we can move to the next thing. Now, guys, remember I told you guys that cloud services are being offered over the internet for customers to make use of, right? That's pretty much what we spoke about in the last class. Cloud services are provided over the internet for people to make use of. So when I talk about public cloud, what do I mean? Guys, with public cloud, the cloud provider, with public cloud, right? With public cloud, the cloud provider provides services, okay, to everyone. Okay, so guys, when we talk about public cloud is a cloud platform where the cloud provider provides services. It provides cloud services to everyone, so anyone can make use of the service. So anyone who has access to the internet can make use of the service. For example, AWS services. Right? So with public cloud, what happens is that the cloud provider provides cloud services to everyone. So the services provided by public cloud will be available for everyone. So everyone who has access to the internet can make use of the services. Does that make sense, Lewis? So you just need to get into agreement, right? And you can make use of those services. For example, AWS is a public cloud platform because AWS services are available for anyone to make use of it. Is that clear, Miriam? AWS services are available for anyone to make use of it, right? AWS does not say, hey, Lewis, you will make use of this service, and then, okay, Miriam cannot use the service. No, when you're using AWS, you can make use of all of the services provided by AWS, right? So AWS is public cloud. Now, when we talk about private cloud, what do we mean? Now, with private cloud, the cloud provider, with private cloud, the cloud provider provides services, okay, to a particular organization, okay? So we talk about private cloud, the cloud provider provides cloud services. So the services provided by a private cloud, okay, are for a particular organization. That's just simply what private cloud is, right? So the cloud provider builds cloud services and makes the cloud services available for a particular organization or for a particular individual. Now, Miriam, AWS too can be seen as a private cloud. What do I mean by that? What do I mean by that, Brian? AWS AWS, Azure, and all these platforms that offer public cloud, where their services are available for anyone to make use of it over the internet, right? AWS too provides services to the US government, right? So AWS has something called GovCloud, which is only available for the US government. Does that make sense, Mr. Divan? So the US government is that institution, is that organization. So AWS offers, private cloud services to the US government. So instead of the US government hosting their applications on premises, AWS has built data centers, right, in America, and these data centers are hosting services only for what? Only for the US government. Does that make sense? So the Department of Defense, the Department of Finance, the Department of Education, those departments can actually host their applications, store their data on what? On private cloud services provided by who? Provided by AWS. So in that scenario, we see it as private cloud. Am I making sense? Some of you guys who are US citizens, some of you guys are going to get government jobs, and you might be working as a cloud engineer or as a cloud security engineer, and your data, the US government data or the US government applications you'll be securing will be hosted on GovCloud. Okay, so AWS has a cloud service called GovCloud, where AWS is actually providing cloud services to the US government. So those services in that scenario are private, only for the US government. Danilo, is that clear? So the AWS data centers hosting services for the US government are private only for the US government, and nobody else can access them. So in that scenario, we call it private cloud. In that scenario, we call it private cloud. All right, the font size is too small. I'm surprised, guys. The font size is really big over here. I'm on 110. You guys cannot see my screen. Oh. Is it better now? Bobby, can you see my screen? Is it good?
Better now.
Okay, good. Now, guys, thank you. Thank you. Okay, guys. So that is simply what public cloud is, and that is what private cloud is. So with public cloud, the cloud services are provided for everyone. So everyone can make use of those services, right? So AWS, Azure, and AWS, Azure, and Google Cloud, they provide public cloud services. Those services are available for anyone to use. So long as you have access to the internet, you can access those services, you can make use of them and pay for what you use. Right? Now, when we talk about private cloud, with private cloud, the cloud provider provides services to just a particular organization. So those services will be private for just that particular organization. Right? And I'm giving you guys an example of what? Of AWS GovCloud. Even Microsoft has GovCloud. Right? So AWS GovCloud, right? AWS GovCloud, AWS is providing cloud services just for what? Just for the US government. Emmanuel, is that clear? Does that make sense? That's just simply what public cloud and private cloud is, right? So you realize that, most companies that are not government companies, most of them, they host, when they're using cloud, they use public cloud, right? So they host their applications and their data on public cloud. And most US government organizations or departments, when they want to use AWS or when they want to use Azure or when they want to use Google GCP, they'll make use of what? They'll make use of GovCloud, because those cloud platforms provide services to the US government, and they call it GovCloud. So that's private cloud. Then you have hybrid cloud. Now, when we talk about hybrid cloud just simply means that the organization is making use of a mixture, right? Is making use of a mixture of public cloud and private cloud. That's just simply what hybrid cloud is. So with hybrid cloud, you're just using it's just a mixture of public cloud and private cloud. That's just simply what that's just simply what hybrid cloud is. So it's just a mixture of public cloud and private cloud. That's pretty much what hybrid cloud is. Okay, that's pretty much what hybrid cloud is. So what we've learned so far in terms of IT infrastructure, what we've learned so far is a company can be on premises, a company can be on the cloud, right? A company can be on premises, a company can be on the cloud, but the company can even be hybrid. Now, when I talk about on premises, what do I mean, Bradley? On premises simply means that the company owns and operates their applications and application data on on a data center they manage. Okay, that's simply what I mean by on premises. So when we talk about on premises, I'm talking about the fact that the company would be hosting the applications, storing their data on what? On a data center that they own and manage. They might not own it, they might even be renting it, right? They might not own it, they might even be renting it, but that the hardware servers they will be the one managing them and things like that. So when a company is on premises, if somebody says, hey, we are actually on premises right now, Jeff, what they mean is that their applications, their data is actually hosted where? On the data center that they own and manage. Does that make sense? That's just simply what we mean by on premises. Okay, Angela, is that clear? I can see you shaking your head. That's good, Mama. Now the next thing, cloud. So it's either a company is on premises or they are cloud. Now, what do we mean by a company is cloud? So if the company is a cloud, is on cloud, it means that they host the applications. They host the applications or data through what? Through cloud services. Through cloud services. All right? Through cloud platforms. Yeah, through cloud service platforms. Right? Like AWS, like on Azure, or maybe they're on GCP or on Oracle. I don't want to hear that cloud. Oracle cloud is a very poor cloud platform, guys. But yeah, that's pretty much what we mean. So if a company says, hey, we are all cloud, right, Angela? If a company says we are all on the cloud, it means that they are using cloud services to host their applications and store their data. That reduces the operational overhead of having to manage data centers by themselves or manage hardware servers by themselves. Right? So if a company says they're in the cloud, it means that they are using a cloud provider. A cloud provider is providing them cloud services, right, which they are using and only paying for what they use. And they really don't care about what? They really don't care about the underlying hardware servers where those services are hosted. The person providing the service to them takes care of that. That is his responsibility. Right? So that's pretty much what we mean by a company being in the cloud. Now, if a company says they are hybrid, okay? So if a company says they are hybrid, it means that they are both, they host the applications in the cloud and some on premises. Okay, so actually, guys, I've worked in companies where they are hosting some of their applications on premises and they are hosting some of their applications on the cloud. So such a company is using a hybrid model. Does that make sense? Such a company is using a hybrid model. So when a company, Anita, when a company is hosting some of their applications on premises and hosting some of their applications on the cloud, it means they are hybrid. Jenny, does that make sense? Perfect. Perfect. That's just simply what we mean by hybrid. That's what we mean by hybrid, guys. That's what we mean by hybrid. Okay? That's what we mean by hybrid. If you have any questions, just drop it on the chat. Okay? Now, guys, apart from that, you will hear something like multi-cloud. You hear something like multi-cloud. Right? What do we mean by multi-cloud? Multi-cloud. So, guys, with multi-cloud, it means the company is hosting the applications and data across different cloud platforms. Does that make sense? Anita, does that make sense? So think about it like this. Imagine you're working in a company and you're using both AWS and Microsoft Azure. Right? Imagine you're working in a company and they're using both AWS and Microsoft Azure. So what does that mean? It means they are multi-cloud. Right, Steven? Because they are hosting some applications on AWS and they're hosting some applications on Azure. And you know that AWS and Azure are cloud platforms. It means the company is multi-cloud. Okay? So there are some companies that are multi-cloud, right? So with multi-cloud, the company hosts their applications on multiple cloud provider platforms. And you guys know the different cloud provider platforms, right? AWS, Azure, GCP. So a company can be hosting the applications on Azure and AWS. That makes a multi-cloud. Okay? So you actually find situations where some companies are hosting their legacy applications on their on-premises data center. And then they are hosting some of the applications on AWS, and then they are hosting some of the applications on Microsoft Azure. That means they are a mixture of multi-cloud and on-premises. Right, Tita? That's simply what I mean. So guys, these technologies are very important. So Kelly, if I should ask you tomorrow, what does on-premises mean? On-premises means a company is hosting their applications on their own data center. So they are managing the data centers, right? They are managing the data centers, they are managing the hardware servers, they are managing the physical networking, they are managing the hypervisor softwares, they are managing all of that. Right, Kelly? That's simply what we mean by on-premises. The company is hosting the applications on a data center that they manage, that they own and manage. Right? If I ask you, what does it mean by a company being in the cloud? If a company says they are all cloud, they are all in the cloud, it means that they are hosting their applications or their applications data on cloud platforms like AWS, Azure, or GCP. That means they are using cloud services. They are using cloud services to host the applications or the application data. And the cloud services they are making use of, Kelly, those cloud services fall under one of these cloud service delivery models. Is that true, Tita? A cloud service must fall under one of these models, right? It's either a cloud service falls under PaaS, IaaS, or SaaS. Did we talk about that last time, Emmanuel? We spoke about that last time, right? A cloud service falls under one of these categories. It's either a cloud service falls under SaaS. That means that you as a customer using the service, you don't manage anything. Right, Solomon? The cloud provider manages everything, right? That's what SaaS is. With SaaS, you as a customer does not manage anything. The cloud provider manages everything. You just subscribe and use the service. Or that cloud service falls under platform as a service. That means that you as the customer using the service, you only take care of what? Your application and your application data, right? And any other thing will be managed by the cloud provider, right? And then if the service you're trying to use falls under infrastructure as a service, that's IaaS, it means you as a customer using that service, Danilo, what will you have to manage? You have to manage the operating system, you have to manage the runtime, you have to manage your application and your application data. Can you guys remember all of that? So guys, that is how it relates. That's why I asked you guys to go through the record. That's why I asked you guys to go through the record, because you cannot come to learn something, right? And you don't really understand the backbone of it. Then you're wasting time. Go through the record once, twice. Once, twice. Get yourself familiarized with these technologies. Okay? Very, very important. Very, very important, guys. All right. The last thing we'll talk about, which I gave you guys as an assignment, is the benefits of cloud computing. So we're going to spend about 5 minutes here. I don't want to rush. No, I want to take my time. I know I'm already past time, but I want to take my time to explain certain things. We started about 7:36 or 37, right? Let's talk about the benefits of cloud. Then we're going to close this topic for Cloud 101, right? Then we're going to get into something else. All right? Now, my people, what are the benefits of cloud? What is the benefit of cloud? We spoke about it last time, but we did it passively, right? I'll come to your question, Danilo. On the chat, guys, what are the benefits of cloud? Right? What are the benefits of cloud, guys? You guys said the cloud, with cloud, it is cheaper, right? It's cost effective, right? So cloud is cost effective, right? So there is reduced cost of ownership. There is reduced cost of ownership while leveraging what? While leveraging cloud platforms. While leveraging cloud. So as a customer, when you're making use of cloud, first, you don't have to bother about hardware servers anymore. The person providing cloud services to you will take care of that. Right? So it is cost effective. Right? Like earlier in the past, like people who were on premises, they have to buy hardware servers, they have to configure those hardware servers. When the hardware servers get full, they have to buy more hardware servers. If something happens to the hardware server, they have to fix, before having to still pay for people who are going to host those applications on the hardware servers, and maybe pay for the internal security and pay for the space where they're going to keep the hardware servers and things like that. Right? But when you're making use of cloud, you don't have to bother about the hardware server. The cloud provider providing the cloud service to you will manage that. What do you take care of, guys? You simply just take care of the application or your application data. It all depends on what service delivery model you're making use of. Right? Perfect. The cloud is so one other thing why we say cloud is cheap is you only pay for what you use. Is that true, guys? Is that true? You only pay for what you use. When you're using a cloud service, you only pay for what you use, Solomon. Right? You cannot be paying for something you've not used. Right? You cannot be paying for something you don't use. Guys, please pay attention as much as you can. So if somebody wants to ask you, what do you recommend for a company to go to the cloud? Because the cloud is cheaper. That means it is cost effective. The reason is because with cloud, you don't have to buy or manage hardware servers. Right? That is not your responsibility. It's the responsibility of the cloud provider. There is reduced cost of ownership. Right? So total cost of ownership is reduced because you don't have to buy hardware servers and all that. With cloud, yes, you make use of cloud services provided by the cloud provider, and you only pay for what you use. If you're not making use of something, you're not going to pay for it. That's simply why cloud is cheaper. Right? Now, apart from the fact that the cloud is cheaper, what else? Cloud platforms are secured. Okay? So some people feel like with cloud, there is better security. So when you take a look at the trends, guys, when you take a look at the trends as to when companies used to make use of on-premises data centers, the amount of cyber attacks companies used to face when they were on premises is a lot more as compared to when they moved to the cloud. And the reason is because when cloud providers build data centers and build cloud services, they go through rigorous audits, security audits. Okay, Jenny, when cloud providers build data centers, right? And when they build services on those data centers, they go through rigorous audits. Does that make sense, Anita? So they're going to have like so many they'll have like so many companies that will come and assess the data centers, do audit of the services to make sure that those services and those data centers are secure. Okay, so that is why with cloud, right, we can say that with cloud it is more secure. First, statistics have shown that most companies used to undergo a lot of cyber attacks when they were on premises. And the attack surface has greatly reduced as these companies started making use of cloud platforms to host their applications and store their application data. Okay? So that's one thing that's how you back up that point. That's how you back it up. Now, one other thing that you're going to look at, yeah. I think it's Elange. I'm sorry if I'm not pronouncing the name right. Is it Elange or Elange? I'm sorry if I'm not pronouncing it right. She says it's more reliable. And Chimamanda says that faster deployments, switch. Right? So cloud is more reliable. Why, guys? Why is the cloud more reliable? Guys, the way cloud platforms are built, services are scalable and they span across multiple data centers. So the way services are built, right? The way services are built, cloud services are built in such a way that they are highly available and they don't fail easily. Why? Because these services span across multiple data centers. So high availability is a very big thing. The way cloud providers host cloud services, okay, they have these cloud services spanning across multiple data centers. And because of that, the probability of a service going down is very low. The probability of a cloud service going down, right? The probability of you not being able to access a cloud service, right? Maybe because of scalability or availability is very, very low. You guys are going to see that, right? You'll see that next week when we start talking about AWS. You will talk about the global infrastructure and you will see how reliable cloud services are. So cloud services, when they are built, they span across multiple availability zones, right? Just to ensure that there is high availability. So the probability of the cloud service going down, the probability of you not being able to access the cloud service because it went down is very low. Does it happen? Yes, it does. But what is the probability? Very low. So it's very reliable, right? Now, cloud has given room for innovation. Guys, there are a lot of them. I'll put that here on the document, and you guys can always read it. So cloud has given more room for innovations, and I'll tell you guys why. Guys, when companies used to be on premises, they used to have some issues that acted as blockers for innovation, which I want to share with you guys. Now, just imagine, Jenny, that your company is on premises, right? And for some reason, you guys are getting short of funds or getting short of hardware servers. And maybe you're trying to build something new, right? But your company is really focused about resources, right? Your company is so strict about using resources because you don't want to get shortages. And they tell you, well, I understand that you're trying to start something new, but we are sorry, we don't have the amount of resources to accommodate what you're trying to build. But now, Anita, when you're making use of the cloud, remember you only pay for what you use. And cloud providers provides so many different services, right? And because there are so many different services, you have the ability to choose, right? And because you have the ability to choose, apart from that, there are more resources. When you're using cloud, there is the ability to be open to a lot of resources. And as you make use of those resources, that's how it gives room for more innovations. There are more resources, there are more services, and because of that, you can try out those new services and you can build wonderful innovations. Right? The cloud is very flexible, right? That means you can choose. You can choose what service you want to use. For example, you go to machine learning services. There are so many machine learning services. For example, you go to compute services. There are so many compute services that you just need to choose which one you want. You see? So with cloud platforms, you have that ability to, you have that ability to be flexible. If solution A does not work, Stefan, solution B is going to work. Does that make sense? So that is why cloud computing, right, or cloud is more beneficial if you compare it to on-premises. Flexibility. So many services to choose from. If service A does not work for your use case, service B might work for your use case. Right? That's what I mean by flexibility. Then innovations as well. Because there are so many services, you're open to a lot of resources, right? That will give you the opportunity to try out new stuff, right? You can try out new stuff without you being bothered about the fact that you're going to get short of resources. No, with cloud, the resources are in abundant, right? The abundance of resources, and because of that, you can always try out new stuff, and you're not bothered about the fact that you're going to get short of resources. That happens only for AWS, Azure, and GCP Cloud. With Oracle Cloud, you can actually get short of resources. You guys should be careful. So those are some of the benefits of cloud. And you cannot talk about benefits of cloud without talking about the fact that the scalability. Cloud services are very scalable. Okay, cloud services are very scalable. They're elastic. Okay, we're gonna talk about scalability when we get into the class properly, right? But just know that elasticity. But just know that cloud services are scalable, and there is elasticity as well, right? There is elasticity as well, right? We'll talk about what we mean by cloud services are scalable and elastic, and also high availability, and better disaster recovery options. So the cloud offers better disaster recovery options. You can host your application workload in one region and then have a DRO environment for that application workload in another region. Okay? The cloud platforms provide a better ROTO and ROPO. You guys will hear about these two. I don't want to give you guys a lot of information, but just keep this ROTO and ROPO. You're going to hear about it. If I were you, I'm going to just go do research on what ROTO and ROPO means. Recovery time objective, okay? Recovery point objective. Okay, that's simply what it means. So with cloud platforms provide a better ROTO and ROPO. So you can never talk about disaster recovery without talking about ROTO and ROPO. When we get to disaster recovery, we'll talk about that. What does ROTO mean? Right? What does ROPO mean? Anita, that's your assignment, right? So when we come to class next time, you tell us what you understand by ROTO and ROPO. So guys, so there are a lot of benefits. So when using cloud platforms offer a better disaster recovery option. It means that ROTO and ROPO is better for cloud platforms. When you're hosting your applications on cloud platforms, right, disaster recovery options are better. They're far way faster as compared to hosting applications on premises. And thank you for that. Somebody sent something else. Thank you for that. Yeah, Amanda. Deployment, faster deployments, yeah. Deployments too are faster when you're using cloud. There are a lot of services that offer quick deployments and things like that. So yeah, let's just leave it like that for now. And I'll give you guys 5 minutes to ask questions related to Cloud 101. And then we're going to just roll over to what I'd like us to talk about today. So guys, that is the end of, the Cloud 101 lecture. I strongly believe that you guys have understood cloud. I know that there are some people who are still trying to understand it. It's okay. I wish when I started doing AWS, somebody explained to me cloud. I wish I understood what used to happen before cloud. I had no idea, guys. This Cloud 101 lecture, you will not see it anywhere. You will not see this Cloud 101 lecture anywhere, especially the introduction, because I took it upon myself. The way I was taught, the things I never understood. When I decided I wanted to become a teacher, right, I made sure that I explained those things that I felt like if I knew them when I started, I would have been better. That's why I took time. I've taken over about 3 hours just explaining Cloud 101 to you guys. What used to happen before cloud came into the picture, and then what cloud is, the benefits of cloud, and things like that. So, guys, remember, these were the expectations, at the end of the class. So we have the shared responsibility model over there. I'll not talk about it now. So, Danilo, remind me, okay? Remind me, Danilo. Let's talk about the shared responsibility model when we start talking about AWS, okay? Please remind me. We'll talk about the shared responsibility model when we start talking about AWS. Please remind me, okay? Yeah, so I'll just highlight that because that's not been covered yet. So remember, I asked you guys to understand all these different things. So if you've understood these things, be happy about it. If you've not understood it yet, you have access to the class records, right? You can always go through it and get yourself, familiar with the terminologies. All right. Let me give people the ability to unmute themselves. Please only unmute yourself if you want to ask a question. Remember to raise up your hand. I'll give you guys some few minutes to ask your questions, then we'll go to the next thing. All right. Oh, you're welcome, Angela. All right, guys. Any questions? All right, go ahead, Brian. Go ahead. What's your question, brother? Are you there, Brian? Cannot hear you. Is he talking?
Can I go real quick? Sorry.
Oh, yeah, go ahead.
Right. So what I was asking.
Okay, Brian is talking already. Go ahead, Brian. I'm sorry, brother. You're speaking. Your voice is very low. Is it from my end, guys? No, I don't think so.
I mean, can I
Yeah,
get some key
better now.
characteristics of cloud computing?
Can you repeat that? Can you repeat that? I never heard you.
Some key characteristics of cloud computing.
Some keyword.
Characteristics of cloud computing.
I cannot hear what you're saying. Put it on the chat. Put it on the chat.
The key characteristics.
What do you mean by key characteristics? Were you in the last class or no?
Yeah, I wasn't last.
All right. If you mean characteristics like properties, first, cloud computing. With cloud computing, you only pay for what you use. That's the first characteristics. With cloud computing, you don't have to care about underlying hardware servers. That's the characteristics. If that's what you mean. With cloud computing, with cloud computing, you must be making use of a cloud provider, be it AWS, GCP, Azure, if that's what you mean by a characteristic. With cloud computing, you must have access to the internet for you to be able to access cloud services. That is the characteristics. Is that what you meant? Okay. I just want to make sure I'm answering your question, brother. All right. All right. Anybody else has a question? Go ahead, Danilo.
Yeah.
So there's a lady who was trying to talk.
Yeah, it's me.
Yeah,
Uh,
go ahead.
yeah, I have a quick question. So, and forgive me if you already covered it in the previous class. I'll just catch up on the video and watch it. But I wanted to ask, so you covered on-prem, cloud, and hybrid, right? And for cloud, there are three different platforms like AWS, Azure, and GCP.
Not just
So,
three, there are more.
okay,
There are more AWS, there are more cloud platforms, more cloud provider platforms. AWS, GCP, Azure at the top. You have Alibaba, you have IBM, many of them, but that's fine. Go ahead.
okay. So I wanted to ask, so if they're like on-prem, do they use the same ones or there are like different ones that they have to learn specifically to like
Okay.
on-prem? Yeah.
So the reason why you're asking that question, like you've already given the answer for it. You were not in the last class. I will not answer that right now because that means I have to start all over again explaining what I explained. So you go through the class record and then you're going to get yourself comfortable. You're going to answer the question yourself by going to the record. Okay.
Okay.
Yeah, it's okay. You were not in the class, so I don't expect you to understand that. So just go through the class record. Go ahead, Emmanuel. Emmanuel, are you there?
Yeah, I'm here. I just wanted to find out from the benefits of cloud computing, can we say elasticity and flexibility, they mean the same thing, or are they actually different?
Well, with flexibility, I just see it as the fact that with cloud you have multiple options, right? Yes, you have multiple options. That's what I mean by flexibility. There are multiple options. So if option A does not work, you can use option B. That's what I mean by flexibility. So you can choose different services. With elasticity, I see it more of, there are resources in abundance. There are resources in abundance. So that means when you're making use of a cloud service, in as much as you can pay for what you use, you can just keep making use of it, right?
Okay.
Unless you get to a service limit. But for you to reach a service limit is very hard because when you use a service limit, you have a soft limit and a hard limit. For example, in AWS, if you're using a service like S3, you can create just 100 S3 buckets in an account. But when you get to 100 S3 buckets, you've reached the soft limit. So you can reach out to AWS to increase your limit for S3 buckets in the account, right?
Okay.
So with elasticity, I'm seeing it as, there is abundance of resources. Okay, like I said, brother, I'll talk about elasticity. So I don't want to talk about it now because you guys will have a lot of things to put in your head. Like, look at the amount of things people have to keep in their head. On premises, on cloud, hybrid, multi-cloud. There's a lot. So I don't want to keep putting in a lot of information for right now. But I promise you, I'll talk about it and you're going to understand it, okay?
All right, that's good.
Good job, Emma. Go ahead, Danilo.
With all these benefits of cloud computing, right?
Yes.
Do some companies still do on premises?
Yes.
Oh,
Companies hosting legacy applications. There are certain applications that cannot work well in the cloud because of the way they were built, right? And some companies do not want to drop and ship. Some companies do not want to refactor the applications. A legacy application is an application that was built a very long time ago, right? Maybe it was used very old technology. Maybe it used very old technology, right? And because of that, when companies are moving their workloads to the cloud, maybe that legacy application, the way it was built, it cannot be supported on any cloud platform. Sometimes it might not just be the application, it might be, the factor, it might be the other things it depends on, right? So in such scenarios, companies might not want to host their legacy application workloads on cloud platforms. Maybe first they feel like the legacy applications are not compatible with cloud platforms, right? And some companies just feel like they are more secure on premises. Why? Remember, when you're using cloud, the underlying hardware servers where your applications are hosted or your data is stored is not going to be, you don't have control of it. You don't have control over it. Is that true, guys? Is that true? Is that true, Danilo? When you're making use of a cloud platform, The cloud provider manages the underlying hardware servers where your data and your applications will actually live. You don't have control over that. You just trust the cloud provider. Why? Because cloud providers go through a lot of audits, and they go through a lot of audits and security assessments. So you believe that they are handling those hardware servers properly. So some companies see that as, they see that as being insecure because another company is taking care of their hardware servers for them, right? So they might see it as insecure. So in as much as we've said here that cloud platforms are secure, somebody can still come and tell you that, hey, cloud platforms are not secure, and they'll give their reasons why. They'll tell you first, the data and the application workloads you're hosting on cloud platforms, the data and application workloads are actually being stored on hardware servers that you don't own, that you don't manage. That's what they're going to tell you. Does that make sense? And that means that if the cloud provider has placed a backdoor, they can pretty much be seeing the data, they can be seeing the applications that you're actually hosting, right? Then somebody else will say, no, that's a lie. Cloud providers, the hardware servers they use in their data centers, they are encrypted in such a way that they themselves not have access to your data. And that's true, right? Cloud provider platforms, their hardware servers are really encrypted in such a way that even the cloud provider does not have access to your data. He cannot see whatsoever data or whatsoever application code is actually being stored on that hardware server. And that's the truth, because audits have proven that. But somebody else can come and say, no, it's a lie. So yeah, there are scenarios where somebody might feel like, and also when you're using cloud, you need experienced individuals. Does that make sense? When you're using cloud, you need people who are experienced in the cloud. If you don't have the right cloud engineers to help you build a cloud platform, it might become very terrible. It might be very terrible for you. It might become very expensive. If you're not using the right services, cloud might instead tend to be very expensive, right? So if you're not using the right engineers, you might end up having an insecure platform. You might end up having a very expensive platform, right? So at the end of the day, it's just all about making sure that you have the right cloud engineers, and that's why you guys are taking this course, wherein you can be able to provide proper solutions that adhere to the pillars of the well-architected framework. Because if a company does not have the right engineers, they will not be using the right cloud services, and now their bills will become very high, right? If they don't have the right engineers, they might be hosting application workloads and application data, and they might not be securing those workloads well in the cloud, and that can lead to what? Data breaches, right? If you guys can remember in 2018, is it 2018? Capital One had a data breach, and if I tell you guys what the issue was, oh my God. Capital One had a data breach. They were hosting sensitive data on S3, the service where they store data. So for some reason, the S3 bucket was actually public, which meant that people could actually have direct access to sensitive information inside the bucket. And that is what led to the Capital One breach. And Capital One lost millions and millions of dollars. So like I said, at the end of the day, if you're not making use of the right engineers, your cloud platform will become expensive. It will become less secure, and it would pretty much just be treated like an on-premises platform. So that's why the need of the right engineers is very important. All right, I'll take your question, Bradley.
Okay, my question is regarding hybrid cloud. You mentioned earlier hybrid cloud is either both public and private
Yeah,
cloud.
there are three types of cloud platforms. Three types of cloud platforms. Okay, brother. Right? There are three types of cloud platforms. What is the purpose of a cloud platform, Bradley? The purpose of a cloud platform is to provide cloud services to customers. Is that true, brother? Is that
Yes.
true? Perfect. Now, a public cloud platform is a platform that provides cloud services to everyone. So anyone who has access to the internet can make use of the cloud service. Is that clear, bro?
Mm-hmm.
That makes sense. Good. Private cloud, right? Private cloud is a platform that provides cloud services to just a particular organization. So if you're not coming from an organization, you cannot make use of that cloud service. I don't know, does that make sense?
Yes, understood.
Good. All right. Hybrid cloud means that you're making use of maybe a private cloud. That means somebody is providing you private cloud services, and then also you're making use of public cloud, wherein you're using cloud services available for anyone or for everyone. So that's simply what I meant here. There are three types of cloud platforms, public cloud, private cloud, hybrid cloud. But first, you need to understand what cloud is. Cloud means somebody is providing a service to you over the internet. Right?
Yes.
If the person is providing that service only to you, that means that is private cloud because it's only for you. If the person is providing that service and it's available for anyone to make use of, that becomes public cloud. Did I answer your question, brother? Please continue.
Yes. So my actual issue was regarding the second part where you said the hybrid cloud could also be on-prem and on the cloud.
All right, good. Now, this year, this part here talks about the types of IT infrastructure. The types of IT infrastructure, right? So when you're making use of IT infrastructure, where can you be hosting your IT infrastructure? Right? You can be hosting your IT infrastructure on premises. That's what I mean. Right? What means that you own your on-premises, you own your data center, right? And you manage your hardware servers, and that's where you're hosting your application data. That's what I mean by on-premises. Does that make sense?
Yes.
Let me go to the next one if that makes sense.
Yeah, it does.
Okay. Now, cloud, that means that you're hosting your applications and your application data in the cloud. And that will mean you're using either public cloud or private cloud or hybrid cloud. Then, at this level here, when I said hybrid, I just simply mean that when you see a company saying that they are hybrid, right, it means that they are using both on-premises, they are hosting some of the applications on-premises, and they are hosting some of the applications on the cloud.
Okay.
Then you have multi-cloud. That means that the company is hosting they are hosting the application workloads or the application data across different cloud provider platforms. Right? So a company might be hosting the application workloads on AWS and then some of the application workloads on Azure or some on GCP. So that makes a multi-cloud. And I'm happy that you brought me back to this because I know some people got confused as well.
Okay, thank you.
Do you have any other questions? Are you okay with that?
No, that's fine. Understood.
All right. Carson, how are you?
I'm doing great, sir. Okay, so my question is, do companies actually have challenges when moving from single cloud to multi-cloud?
It all depends. If they are trying to migrate what they have on one cloud platform to the other one, they might have some challenges. Or maybe they are trying to build something new on a new cloud platform to make them multi-cloud.
Okay.
I don't know if that makes sense. So for example, if they are trying to migrate some of the applications that they have on one cloud platform to another, yeah, they might face some challenges. Right? First, expertise. Maybe the cloud platforms they're trying to move to, they don't have a lot of expertise on it. Second, they might have network connectivity issues, network bandwidth issues, and they want both cloud platforms to talk to each other. And there are a lot of things that they might face. They might have to refactor the application since they're trying to migrate it from one platform to the other. There are a lot of things that could pose as an issue. But it all depends if they're trying to migrate their existing application or data to another cloud platform, or if they're just trying to build something new on the other cloud platform. That will now determine the kind of issues they'll face. Is that clear?
Okay, sir. Thank you, sir.
All right, go ahead, Lewis.
Yeah, so my question would be like, when you mentioned migration, so when it has to do with
No, I'm not
migrating,
talking about migration. I'm not answering. Yeah, go ahead. Go ahead and talk
yeah,
about it.
this was just like, what would be some of the challenges when migrating from like on-prem into cloud, and like the other colleague classmate who just mentioned migrating multi-cloud. What would be
Yeah,
some of the challenges?
there are a lot. There are a lot of challenges. A lot. The first
Because
one is network connectivity issues. When you're trying to move from one cloud platform to the other, you might not want your data to go over the public internet. You might have to set up something, maybe like a VPN,
yeah,
such as like a VPN solution, just to make sure that your data does not go over the public internet without going through like an encrypted channel. There are a lot, but I'll not answer it for now. Because if you guys ever want to go through like my migration videos, I've taught a lot of migration in the past. You can go through it, but I'll not answer that now. There are some people here who have already gotten a certain amount of information right now. And if I should add another one about migration, then I'll just delete the class. But that's a good question. I can answer it privately. If you care about it, I can talk about it at the end of the class. Okay. All right. I'm sorry, guys. Don't see like I'm trying to be rude, but I'm just trying to control what I give out there. Some people are really like, man, this is a lot of information. So I want to be careful with the things I say. Right. So I like the questions. Okay. So I'll go ahead and I'll say we're done with Cloud 101. I'll stop the recording. Just want to show you guys something. So you guys are going to have access to the drive. Nobody has access to the drive yet. I just gave some very few people access to the drive because they came to the office and I spoke with them. So I just said, okay, let me just give you access to the drive since you're here. But for right now, so this is your drive. This is the name of your class drive, right? This is how you guys want to be called. And you're going to see the folder for Cloud 101. So all Cloud 101 videos will be here. So this record that I just made, I'll upload it here. And for those of you guys who said you don't have access to the drive, nobody had access to the drive. And I beg you guys to pay attention to your class group. If you guys can remember, I asked you guys to pay attention to your class group. This is your class group. This is your class group, right? I've asked you guys to pay attention to this channel on Slack. You should make sure when you wake up in the morning, you look at what has been posted there. For example, last week, last week, as soon as we're done with the class, you see, I gave you guys the link to the drive. When you click on it, it's public. I made this video public. So anybody that clicks on it will have access to that record. But some of you guys never looked at it, right? Second, this is where I pasted the class. You see, look at where I pasted the class. I pasted the class name today at 1 p.m. so that you guys will be ready for class. I've asked you guys. That is how you communicate. You cannot come to do IT and you don't want to be communicating. Then how are you even going to work if you get a job? When you start working, you'll be using Slack. Some companies, most of them, they use Slack. So familiarize yourself with Slack. Familiarize yourself with Slack, right? So that you know how to reach out to people, you know how to communicate on a group channel, so that you get yourself familiarized. I've told you guys, if you're unable to get to me, right, reach out to Azimi Glenn on Slack, right? Reach out to Azimi Glenn or reach out to Kevin Joris. These people are going to talk, they're going to be able to respond to you earlier, as sooner as compared to the way I'll do, because sometimes I'm busier. So talk to them and they're going to help you. If you're unable to get to me, please don't forget that. You cannot be in a class and you don't know what is being posted on your class channel. No, it doesn't work like that. So when you wake up in the morning, Danilo, right? When you're free, you go to the class channel. What has Zashi posted? Or what has Kevin posted? Or what has Glenn posted? Is there something that I should be aware of? Does that make sense, Bradley? That's how we should live. That's our group. That's where we all see information. So let's treat it that way. Very important. Very, very important. All right. With that being said, I'm going to go to the next thing that we'll cover. All right. I'll ask you guys to take just take a 5 minutes break, and then you come back, and then we're just gonna finish till 10 o'clock. All right, guys, take a 5 minutes break, please. So I'll be back at 8:46. All right. Okay, guys. I'm going to just continue from where we stopped. I believe you guys can all hear me. I'll go ahead and share my screen. So we're going to get into the next topic. I believe it's something very, very interesting, which I think, each and every one of you would like to, kind of like understand it. So just pay attention, and I believe that you guys are going to see as something very interesting. By the end of the class, which I think we're going to round up with this tomorrow, I'd like you guys to understand, the following aspects. Some people must have heard about it, some people have not. But I always just call this class, Software 101 and Introduction to DevOps, where you just kind of like you understand certain IT terminologies and all of that. I don't think I'm recording. Give me 1 second. Good. So we're starting with the Software 101 lecture, and I always see this class as a class where I just introduce people into IT, make them understand more IT terminologies. So like the first week of class, you guys will get to hear about a lot of different IT terminologies. And by the end of the class, the couple of things I'd like you guys to understand, theoretically, right? So I'd like for you guys to understand what a code is. So when we talk about a code in IT, what do we mean by that? I'd like for you guys to understand, what we mean by a programming language. This might sound very basic to some people, but to others, it's something that they have been wanting to just have an understanding of, right? I would like for you guys to understand, what a software is, So when somebody says a code, or somebody says programming language, somebody says software, it's good for people to understand, what they mean. And I would like for you guys to understand, the types of programming languages that we have out there, right? I'd like you guys to understand the types of programming languages that we have out there. There are different types of programming languages that we have out there, so by the end of the class, I'd like you guys to understand, what are some types of programming languages that we have out there, right? If you know, that's fine. Just give others the room to be able to understand what I'm talking about, right? And I would like for you guys to understand, how a software works. How does a software work? You guys use softwares every day, right? You guys use softwares every day, right, Brian? Like, for example, today you are taking class on Zoom. Zoom is a software. How does it work? Right? How do people use the software, and how does the software work in the back that we don't see? So I would like for you guys to understand how it works. One other thing that I'd like for you guys to understand, I'd like for you guys to understand, I'd like for you guys to understand the software, the software development lifecycle. Right? I'd like for you guys to understand the software development lifecycle. So this will just simply make you guys know what are the different stages through which, the different stages undergone to be able to, create and manage a software. It's very important for somebody who decides and says, hey, I want to actually learn, IT. These basic terminologies are important, right? I'd like for you guys to understand the different approaches. I'd like for you guys to understand the different approaches used in software development projects, right? So when the company wants to embark on a software development project, what are the different approaches that they're going to use? So you're going to hear about maybe some companies making use of waterfall, You're going to hear about some companies making use of Agile. What does that mean, right? And then apart from that, I'm going to now talk to you guys, about DevOps. I'll talk to you guys about DevOps. What does DevOps mean? What does DevOps mean? And give you guys, give you guys an overview of how a CI/CD pipeline might look like, right? Maybe just give you guys an overview of how a CI/CD pipeline might look like, right? So, by doing this, guys, I'm not teaching this to scare some of you, but I'm just making you guys understand, some of those different IT terminologies out there so that you start getting yourself acquainted. Okay? So at the end of the class, these are the things I would like for you guys to understand. At the end of the class, these are the things I'd like for you guys to understand, right? So I'd like for you guys to understand, this aspect of things. All right. If there are no questions for now, I'll go ahead and I'm going to start. I'll make sure that nobody can unmute themselves, and I'll just ask you guys to try to follow up as much as you can. All right. I promise you guys that for this last 1 hour, I'm going to talk about very interesting things. And tomorrow as well, I'm going to talk about very interesting things. Trust me, you're going to enjoy it. Now, the very first thing that everybody should understand when doing IT is a code. Okay? What is a code? What is a code? I want you guys to understand that a code in IT is just simply a set of instructions that tells the computer what to do. That is just simply what a code is. So guys, the reason why we are able to use softwares today, right? The reason why we're able to use softwares today is because of code, right? A code is just simply the smallest unit of a software. Okay, so that's just simply what I want you guys to understand. A code is the smallest unit of a software. So what happens is when people want to develop a software, they are going to actually develop code, right? They'll develop code, and pretty much the code is what is going to have that software working, right? So codes are just simply the backbones of a software, right? So you're going to have developers writing code. You have software developers or software engineers writing code, right? So let's say, for example, a company wants to build WhatsApp, the WhatsApp that you guys use every day. And because they want to build WhatsApp has different features. For example, WhatsApp has the chat feature where you're able to send messages to people and they respond to you back. WhatsApp has the status feature where you go put something on you can upload a picture or a video on WhatsApp and it expires maybe after one hour, after 24 hours. WhatsApp has the emoji feature. WhatsApp has the profile picture feature. So WhatsApp has different features. The reason why those different features work is because developers have developed code for every feature. So the reason why every feature functions, for example, guys, when you go and you say, when you go and you try to upload a picture on your status, the reason why that works is because the codes that were written to support that feature executes, right? So when you're trying to upload a picture, what you're simply telling the code is you're instructing the code, right, to have that your picture uploaded on your status. So without codes, right, there is no way a program can be developed or a software can be developed. So a code in computer programming, a code is just simply the fundamental blocks of a software. So a code is just a set of instructions that a developer has written, saying that, hey, code, when you are triggered, do this. That's what the code is going to do. So the reason why we have applications today is behind those applications, what actually executes and runs are codes that have been written by developers. Let me show you guys an example of what I mean. Now, developers write code using programming languages. So for you to be able to develop a code, you need to make use of a programming language. Like I said, some people know about it, some people do not, right? And let me go with the basics so that people can understand and get themselves up to speed, right? So when you want to write a computer code, right, you need to understand a programming language. So a programming language, right, this is the language. This is the language used to develop software codes. Okay, guys? So, there are different types of programming languages. There are different types of programming languages, right? So a programming language is just simply the language a developer will use to develop code, right? So that's why sometimes you might see somebody and he says, oh, my best programming language is Java. That simply means that when the person wants to write his code, he uses Java. You might see someone, the person might say, hey, my best programming language is Python. That means the person wants to write code, he uses Python. That's the programming language of choice, right? When somebody says, his best programming language is Golang or Go, that means when the person wants to write his code, he prefers to use Golang or Go, right? You might see somebody saying, oh, my best programming language is JavaScript. When the person wants to program, he prefers JavaScript. When somebody might say my best programming language is C#. Somebody might say my best programming language is .NET and all of that. So guys, when we talk about a programming language is simply a language somebody will use to develop what? Set of instructions that will tell the computer what to do. So there is no way softwares can be developed if you don't have somebody using a programming language to develop code. Because when a software is running, the software is just executing code, the code that has been written. When the software is running, the software is just executing code that has been written. And codes are developed through programming languages. Okay? So there are different types of programming languages, and they are mostly classified. So for right now, just put this. So programming languages could be classified as front-end and back-end programming languages. So I'll just leave it there. So guys, so you might so when developers are developing code, right? They might be developing code. They might be developing code using front-end programming languages, or they might be developing code using back-end programming languages. Do you guys know what front-end and back-end is? No. So I'll talk to you guys what front-end is, what back-end is. You guys will understand that, and this will make sense. Okay? So I'll not talk about that right now, but just understand that a programming language is just simply the language that, the language that is a language that is used to develop software code. All right? So like I said, a couple of them. You have Java, it's a programming language. Python, those are the two most widely used programming languages in the world. You have about Python, you have about Java, you have about Golang, you have about .NET, you have about C#, you have about C++. Those are different programming languages, right? And you have about HTML, so they are being classified under back-end or front-end programming languages, which we're going to talk about. All right. Now, we've understood what a code is. So a code is just simply a set of instructions that tells the computer what to do, right? Codes are just simply the smallest unit of a software. So for softwares to be developed, codes need to be written, right? Now, since we've understood that, we've also seen that codes are developed through the use of a programming language, right? And we've seen that there are different types of programming languages, and those programming languages can be classified under front end and back end programming languages, right? We're still going to understand that as well. Apart from that, I would like to talk to you guys about the software. So what is a software? Guys, we all use softwares every day. We all use software products every day. For example, you guys are talking to me now through Zoom. Zoom is a software. It's a software application, right? You guys use WhatsApp every day. There are some people who are on TikTok every day, right? There are people who use Netflix every day. There are people who actually make use of cloud services every day. There are people who actually use Gmail. They use those things every day, right? Guys, those are all products of a software. So guys, what is the software? Right? So I'd like us to talk about, what the software is, right? And then we can talk about components and things. So when we talk about a software, I will just simply say that the software is a collection of codes which have been built to provide a particular service or to handle a need or to handle a request. That is just simply what a software is, right? So guys, when we talk about a software is just a collection of programs or a collection of codes that have been written and built to actually offer a particular service. So let me give you guys an example. Guys, you're going to see scenarios where people need something. For example, about 15 years ago in America, there wasn't like any app that we could use to send money to our families back home. Do you guys all agree? For those of you guys who have been in America for a long time, for those of you guys who are in Europe, so many years back, guys, there wasn't any application that we could use to send money to our family back home. The only application that was usable was maybe something like Western Union. That means you have to go to Western Union and give somebody like a banker the money, and then they send that to your family back home. Now, it meant that there was a need for a software that people could use to send money back home, and that's why right now we have a couple of different softwares out there, right? For example, you guys will see Warrior Meet. Now you even have the Western Union app that you can just simply use to send money back home. So the reason why softwares are developed is because they are developed to solve or render a particular need. That is the purpose of a software, right? A software is developed, a software is built to do what? To render a particular need, right? For example, so many years ago, there wasn't any application that people could use to come online and talk with others in different parts of the world. At first, there wasn't even WhatsApp. So you could not actually go online or maybe Facebook or WhatsApp. There wasn't any application like that, right? So because someone saw the need for people in different parts of the world to be able to communicate, what did they do? They developed, applications like that, like WhatsApp or Facebook or Instagram. Those are all softwares that they have developed, right? So when we talk about a software is just simply a collection of codes which have been built, right, to do what? To render a particular service to people. So without softwares, a lot of things in life today will not happen. Like without softwares, there will be no way we can chat with our family back home. Without softwares, there is no way, we could even send money back home. Without softwares, there'll be no way we can do some basic, or normal life activity. So softwares have really helped us. Some of you guys even have Alexa in your house, right? And you tell, hey Alexa, turn off the light. Alexa turns off the light. That is a software. Alexa is a software. Maybe you tell Alexa, hey Alexa, play music. Alexa plays music, right? So guys, the reason why all of those things work is because people have developed codes and have used the codes to build, a software, and that software is what is rendering or offering that particular service to you. That's just simply what a software is. Now, there are two types of softwares. Okay, there are two types of softwares that you guys will see or that you guys will hear about, right? So you have operating system softwares. Okay, and then you have application softwares. Okay, so these are the two types of softwares that you're mostly going to see, right? So when we talk about an operating system is a software, right? I gave you guys an assignment to go research what the different operating systems are. So in IT, there are different operating systems, right? You hear about operating systems like what? You hear about operating systems like Linux, Windows, Mac OS. Those are the different operating systems you're going to hear about in IT. So what is an operating system? Now, my people, an operating system, right? OS, right? An operating system is a software. An operating system is a software that is used to manage computer hardware. Okay, so an operating system software is a software that is used to manage computer hardware and the programs hosted on it. So Angela, the reason why you are able to use your phone today, right? The reason why you're able to install apps on your phone, right? Remember, your phone is a hardware, right, Angela? And now you've installed apps on your phone. The reason why you're even able to install those apps and use those apps on that phone is because of what? The operating system. Every IT device has an operating system. Does that make sense? Hardware servers have operating systems. Computers have operating systems. Phones have operating systems. iPads have operating systems, right? So without the operating system, there is no way computer hardware can be managed. So an operating system is what would manage the computer hardware and then the programs that are hosted on that computer hardware. You guys go out there, you install apps on your phone. The reason why those apps can run on that phone is because of the operating system. The reason why you're able to interact with your laptop, you guys, you use your laptop, you type on your laptop, you type human readable stuff, and then the computer is able to understand what you're typing, is because the operating system is translating that for the computer to understand. The operating system gets your input and then transforms that into binaries so that the computer can understand, and then provides back an output which you can understand, right? So operating systems are very important, and we'll talk about operating system. We're going to have like a whole week where we're going to learn operating system. But you guys should know today, right? Moving forward, you should know that every IT device has an operating system. And if an operating system fails, there is no way that that device can work. So the operating system is the core of every IT device. And the operating system is a software. It's a software that has been developed to manage what? To manage computer hardware and the programs or the applications or softwares that are installed on that computer hardware. Does that make sense, Jeff? Very, very important for you guys to understand. For those of you guys who don't know, some people do know it, right? And it's okay, right? So examples of operating systems that you guys are going to hear about, you're going to hear about Linux, very popular, Windows, and you hear about Mac OS. There are different other operating systems, but these are the most widely used operating systems in the world today, guys. So it's either your device is built from Linux or Windows or Mac OS. And then for your phones, you're going to hear about Android, you're going to hear about iOS, you know, those are operating systems, and they actually come from Linux or Windows or Mac OS, just so you guys know. So I want you guys to be aware of that. So that's pretty much what an operating system is. All right, so like I said, OS means operating system. Okay, so somebody should ask you, in your company, what OS do you guys use? It means operating system, right? So if in your company, somebody asks you, or if you go for an interview, somebody asks you, what OS are you familiar with? The person is just simply asking, what operating system are you familiar with? All right, the next thing I'll talk about will be application software. Okay, so that's the next thing I'm going to talk about. Application software, right? Now, so application softwares are just simply programs. These are software programs. Okay, so these are software programs. These are software programs. These are software programs used to render a particular service to people, right? For example, Zoom is an application software, right? TikTok is an application software. WhatsApp is an application software. Tinder, dating app, it's an application software. Facebook is an application software. Guys, there are so many of them. So all of these things you guys call apps, those are all application software, right? And the purpose of an application software is to render a particular service to someone, to a customer, right? So do you guys really think that somebody will go spend time writing codes to build a software application if that will not be used to provide a particular service? Even like the cloud services that I told you guys that cloud providers have built cloud services. These cloud services that they have built are actually softwares. They're softwares. Cloud services are softwares too, right? Because cloud services are built to provide IT customers the ability to carry out certain IT needs. Is that true, Emmanuel? So we can also consider those to be what? To be application softwares. Cloud services are application softwares because they are developed to do what? To provide IT customers the ability to perform, you know, certain IT needs, right? So I want you guys to be aware of that. I want you guys to be aware of that. So guys, that's one thing I want you all to know. All right. We're talking about that. Now, I'd like for us to understand the components of a software. Let's understand the components of an application software. Let's understand the components of an application software. The components of an application software. It's good for us to understand that. And the way I'm going to teach that, I'll teach that by simply doing an illustration. I'll teach that by doing an illustration so that, you know, you guys can all see. Now, guys, I want all of you seated here today to know that, so to those of you guys who don't know, I want you all to know that all applications, be it Zoom, be it WhatsApp, be it, you know, FaceTime, be it, you know, Slack, be it, you know, Instagram, any Snapchat, any application you are making use of, I would like you to understand what are the key components of every software application. Now, Tita, brother, every software application has a front end. Okay? Every software application, right? Every application software has what? Has a front end. That's one thing I want you guys to know. Every application software has a front end. And we'll talk about what the front end is. And every application software has what? Has a back end. Okay? So those are the key parts of every application. So every application has a back end and a front end and a back end. Now that means that, guys, when companies want to build an application, who does that? A software developer is going to do that. Okay? So when companies want to build an application, right? When they want to build an application, remember, this application will be developed from the writing of code. Right, Emmanuel? It will be developed from the writing of code, right? So who does that? A software developer, right? So softwares are developed by software developers. If you're here, turn on your camera and follow up. It's very, very important for you. Very, very important for you, right? Very, very important for you. Okay? Very, very important for you. If you're here, turn on your camera and follow up. If you're not following up, I assure you that you're not going to make more than 1 month here. You're going to run away. Follow up. It's very important. Follow up. Don't bother. You guys remember this day I told you to follow up. Now, guys, I want you all to understand that softwares are developed by software developers. So software developers actually develop the code used to build the software applications. And you're going to realize, Danilo, that, like I said, a software has two parts, right, brother? The front end and the back end. Now, what's the back end? What's the front end, Lewis? What's the front end of an application? All of you guys go to WhatsApp. All of you guys who use WhatsApp, go to WhatsApp. All of you guys, go to WhatsApp, guys. All of you, go to WhatsApp. All of you. Just go to WhatsApp. All right. Ladies, are you guys on WhatsApp? Are you on WhatsApp? Good. What you see right now, that is the front end of WhatsApp. So the WhatsApp application that you guys are using every day, right? You access it through the front end. All of you guys go to Slack. I don't know if you have Slack on your phone or your laptop, but go to Slack, guys. All of you go to Slack. All of you go to Slack. All of you go to Slack. All right. You guys are taking a look at Slack. What you are seeing now on Slack, that is the front end. So what do you mean by front end? Now, guys, the front end is the portion of an application that permits clients to interact with the application. Who are clients? Us, right? We who are accessing the application, right? So like I just told Lewis to go to WhatsApp. Lewis is a client, right? Valerie is a client. I'm a client because I use WhatsApp, right? So we talk about the front end. The front end is the portion of the application, okay? The front end is the portion of the application, right, that permits any users to be able to interact with the application. The front end of the application is a portion of the application that end users access to be able to interact with the application. Okay, so let's write that down because it's very important. You guys have been using application front ends every day, but you don't know, right? So, this is the portion. This is the portion of an application through which end users can access so as to can access to interact with the application. Right? It is true. It is true. It is through the front end. It is through the front end that end users of an application can submit their request. Right? Lewis. So for example, you guys use WhatsApp. When whatever thing you're doing on WhatsApp, right, is a request. Whatever action you are trying to perform on WhatsApp is an API request. So Danilo, you write a message and you hit enter. What you've done is you've submitted a request. You go to your status, you are trying to upload a picture. What you're doing is that you're doing what Danilo, you're performing an API request. You're going to your profile picture on WhatsApp, you're trying to change your profile picture. What you're doing is that you're submitting an API request. So you're doing that through what? Through the front end. Does that make sense? You're doing that through the front end, right? So guys, the front end of an application is just that portion of the application through which you can interact with the application, right? So that portion provides you, a GUI. It provides you a GUI interface through which you can do what? You can interact with the application, right? So whatsoever action you're performing through the front end, that is considered to be what? An API request. So whatsoever action, so when you go to, like for example, WhatsApp, you try sending a message, right, and you hit enter. What you're doing is that you're performing an API request. You're going to your status, you're trying to upload a picture, right? What are you doing? You're performing an API request. Or you go to your status, you're trying to delete a previous status you uploaded. That's an API request you perform. Or you go to WhatsApp, you try to change your name, your name on WhatsApp. That's an API request. So whatsoever thing you're doing on an application, you are performing an API request as an end user. So for you to be able to interact with an application, you need the front end. Now, Lewis, there are two ways an application front end is made available to end users. There are two ways, okay? There are two ways an application front end is made available to end users, right? So guys, you guys are going to realize that there are some applications that we use that can be accessed through the web browser. And there are some applications that we use that can be accessed as mobile apps. You guys all agree? What do I mean by a web browser? Like if I come here to my browser here, look here, like Amazon, I can go to the Amazon website, right, through my browser. So you see that you can see that I'm accessing this Amazon application front end now through the web browser. So there are times when certain applications, right, their front ends are offered through the web browser, right? That means you have to go to your web browser, you put the domain name to access the application, and you access the application front end. This is the application front end of Amazon, right? This same Amazon site, right, you can also access it through a mobile app. You guys all agree? You can also access it through a mobile app. So guys, what I'm saying is that most front ends are delivered in two ways. It's either a front end is delivered as a web, is delivered through the web browser. That means you'll be accessing it through what? You'll be accessing it through your browser. You put the domain name, you access the front end like this, for example, right? Or even Facebook. You see, if I was to go to Facebook, you see, guys, you see, Facebook too Facebook too can be accessed through the web browser. That's the first way an application front end can be delivered. The second way an application front end can be delivered is through a mobile app. Guys, can we install Facebook on our phones? Do you guys all agree? Can you have Facebook on your phone? Can you install Facebook on your phone? Yes. That is actually the front end of Facebook you're installing, right? So you can actually install Facebook on your phone to be able to access the Facebook front end. So you're using what? You're using the mobile app client. So it's either you're accessing a front end through the web browser client, or you're accessing a front end of an application through the mobile app client. Right? That's just simply what happens. So when developers are developing applications, they are going to decide, should this application only be accessed through a mobile app? Or should it be accessed only through the web browser? Or should it be accessed through both? So what happens is that, Danilo, if they want the application to be, if they want the application front end to be accessed through a mobile app, what do? They'll create a client which people can install on their phones, and through the client, they can access the front end of that application. So when you install WhatsApp on your phone, you are not installing WhatsApp application. No. When you install Facebook on your phone, you're not installing the Facebook application on your phone. No. You don't have the application, so you cannot have the application on your phone. What you're installing on your phone is the client, the mobile app client for that application. So through that mobile app client, you can access the front end. Am I making sense? Am I making sense? So when you install WhatsApp on your phone, what you're installing on your phone is the WhatsApp mobile client. And through the WhatsApp mobile client, you'll be able to access what? The WhatsApp front end. Right? When you install Facebook on your phone, what you're installing is the Facebook mobile app client. And through the mobile app client, you'll be able to access the front end of Facebook. Confused. Somebody says, no, you don't own WhatsApp, so you cannot have WhatsApp, the WhatsApp application on your phone. No, what you're installing is the client. The client is what permits you as a customer. The mobile app client is what permits you as a customer, okay, or as a user of the application to access the front end. So that client, you've installed it on your device, so you can use the client to be able to access the application front end. Because that application front end is seated somewhere, it's there on a server somewhere, which you don't own, right? So you're not installing the application on your phone, you're installing the application client on your phone, so you can use it to access the front end. So, leaving from class today, I want you guys to understand something. I want you guys to understand that the front end of an application, or the front end of an application, the front end of an application can be accessible either through the web browser or through a mobile app client. Okay? The application owner decides. The application owner decides on how to expose the front end, of the application. Okay, so that's one thing I want you guys to be aware of today, guys. So when you are accessing WhatsApp through your phone, what you've simply done is that you've installed the WhatsApp mobile app client, and that WhatsApp mobile app client that you install on your phone is what is permitting you to be able to do what? To be able to access the WhatsApp front end. Okay, so that you can be able to interact with WhatsApp. Okay, so when you install WhatsApp, when you access WhatsApp from your phone, it's not like the application is living on your phone. No. You are accessing that application on a server. The application is hosted on a server somewhere. Let me show you guys something. You see this entire diagram I drew, right? Remember, guys, what I taught you guys on the first day of class is that your application is hosted on a server somewhere. Okay? So this is your application. The front end and the back end is hosted on the server somewhere. That's what happens. All these applications that we use, they are hosted on a server somewhere. So what happens is that when we want to access the application, okay, as an end user, imagine this an end user, when you're trying to access the application, what happens is you access the application over the internet, right? When you're trying to access the application, you're trying to access the front end. And there are two ways you can access that front end. It's either you access the front end of the application through what? The web browser, or through what? A mobile app client. So you might have to install the mobile app client on your phone to be able to use that mobile app client to access the application front end, right? Or you might do what? You might maybe just use your device browser to be able to do what? To be able to access the application front end. So that application you're accessing is not on your phone. It's not living on your phone. No, the application is living on a server somewhere. So you're either using your browser to be able to access the application front end, or you're making use of what? A mobile app, if the application permits it, or you're using a mobile app client to be able to access the application front end. But the application is seated somewhere on a server somewhere, and through internet, you are accessing it, maybe through the browser or through a mobile app client you've installed on your phone. All right, I'll stop here and I'll get questions, because what I said was so technical. Okay. All right. What are the questions? What question do you have, Emma?
Yeah, so I'll start with front end developing, but I just want to ask, what is the difference between front end developing and UI UX design?
Oh, it's the front end developing, like the people who develop the code that will be used to build the front end of the application. So front end developers are those who build. So in software development, I told you that softwares are developed by software developers, and you have the front end developers. And what the front end developer does is that the front end developer will be the one to develop the front end of an application. Does that make sense? So what do I mean? They write the codes used to develop what? To develop the front end of an application. So it's either that means that they might be familiar with front end programming languages. Does that make sense? So you have front end programming languages like what? Like HTML. Okay? You have front end programming languages like HTML, JavaScript, CSS. Mostly when you're dealing with mostly when you're trying to expose your front end through the web browser, they'll be using a language like this. Right? So front end developers are those who develop the front end of an application, and they have expertise with such programming language. HTML, JavaScript, CSS. They are familiar with something like that. Right? Now, a UX designer, just from the name designer, the UX designer is a UX designer. He has the picture of how the front end should look. He designs a picture of how the front end should look. For example, the cat should be on the top right-hand side like this, right? So a UX designer just designs, a picture of how the front end of an application should look. Does that make sense? The colors that should be used, he designs it, but he cannot code it, right? The person that develops the codes that will build this front end, like you guys can see, for example, the person that does that is the front end developer.
So that means they have to like work together. The UX
they
and
work
the front.
together. So the UX designer tells the front end developer how the front end should look, and then the front end developer develops the code. So you might be using HTML. Guys, look here. Like every application front end that you guys see that is accessed through the browser, that is developed through HTML. So HTML is the programming language that is used to develop front end that is used to develop the front end of an application, right? So HTML gives structure to your website. So when we talk about so guys, like I said, there are two ways an application can, a front end can be delivered. It's either through a web browser, and if an application is being delivered through the web browser, it means that it's a website like this. This is a website, right? When we say website just simply means that you are accessing an application front end to the web browser. That's simply what a website is. A website just simply means you are accessing an application through what? Through the web browser. This is the front end. All right, and it's offered as a website, right? Or the application will be offered through the front end will be delivered through a mobile app client. That means you install the mobile app client on your phone, and through the mobile app client you can access the front end, right? So front end developers will develop the front end of an application, and they will make use of a language like HTML. So HTML is what gives structure to your website. HTML is what gives structure to your website, right? HTML is what gives structure to your website. And front-end development is kind of like easier when you compare it to like back-end, because now front-end has a lot of assistance with AI and other platforms that permit you to just, build stuff, without having to even write code and things like that, right? But yeah, that's pretty much what front-end is. Does that make sense? So it's either your front end is delivered, if the front of an application is delivered through the web browser. And if it's delivered through the web browser, it means you'll be accessing the front end through a website, right? Or the front end of an application will be delivered through what? Through a mobile app client. So it means that you'll be accessing the front end of the application through a mobile app client that you install on your device. So you install a mobile app client on your device, and through the mobile app client, you can access the front end. That's just simply what happens. Yeah, go ahead, Mama. What's your question, Angela?
Yeah, sorry. I was just wondering, is there like a phone which uses like Linux as an OS?
Can you repeat that, please?
I was wondering if there's like a phone, like a mobile phone, which uses Linux as their OS.
I think Android is built on Linux, if I'm not mistaken, or through. You guys can check. But these phone OSs, they are built from either Mac or Linux, if I'm not mistaken. Yeah, normally you have two, Android or iOS, right? So for example, if you're using something like Samsung or Techno or any of those, it's built on Android. And then if you're using something like an iPhone, it's built on iOS. But I think iOS is pretty much from the Mac OS operating system. All right. So did I answer your question, Emmanuel? Did I answer your question? Yeah, so that's just simply what the front end of an application is. So is this what you guys be doing? No, but it's good for you guys to just have an understanding of how these things work. I don't expect you guys are not going to be building application front and back end. But is it good for you guys to understand what it is? Yes. Right? Because you're learning IT, right? IT is all about applications and hosting application data. So understand how applications work. It's important, right? So as end users, you're accessing an application through the front end, right? Now, look at something, Angela. An application only has a front end. The application will not be active. It will be dead. Okay? If an application only has a front end, that's why, guys, if you go to some websites, when you click and click, nothing happens. Have you guys realized that? There's some websites that when you go to, you just click and click, nothing happens. A place where they say input your name, your first name, last name, you put that, nothing happens. Why? Because it has no backend. So an application without a front end, an application that has just a front end, maybe it could just be like a static website, right? Where there is no backend, that application is a dead application. What makes an application functional is the backend. The backend is the core of the application. The backend of an application is the core of the application. Now, what are the components of the backend? The first component of the backend, okay, is the API. Okay, application programming interface. Okay? Then you also have what? You also have the business logic. That's the application code. So you have the business logic, right? In bracket, the backend code. Okay? And then you also have the database. That makes what, guys? That makes the component of the backend. Database. So you guys are going to see short form DB. Anytime you see DB, DB means database. So, my people, this is what makes the backend. Like I said, the backend is what processes every request that comes from the front end. Now, let me explain to you guys what happened. Let's go to the first part of the backend, which is the API. Now, Angela, look at something, Mama. Drop your pens and just look, all of you. Let's say, for example, right? Let's say, for example, Angela is on WhatsApp and Kelly is on WhatsApp. And let's say, for example, Emma is on WhatsApp. Right, Emma? Look at what happens, brother. Angela, when you go to WhatsApp and you're trying to do something, let's say, for example, you're trying to upload a picture on your status, Angela. The time when you put that picture and you click on upload, look at what happens. When you click on upload, what you're doing is that you are performing an API request as an end user, right? So through the front end, you are trying to perform what? An API request. Now, what happens is that the back end, right, has an API which connects the front end to the back end. So anytime you perform an action on the front end, for that your request to be processed, the API would take that your request and send it to the back end to process it. So, Emmanuel, the reason why people are able to upload something on their status is because through the front end, they have placed that request, and the API has taken the request. Okay? So the API, what does the API do? The API acts as a server. I say, hey, Kelly, go bring me water. Kelly goes, go get me water from somewhere and comes and give me. That's the purpose of an API. So the API receives requests from the front end. So, Angela, what is request? Whatever thing you are trying to do on the application. If you are trying to send a message, if you are trying to upload a picture of your status, if you are trying to do a phone call, right? That is what? That is a request. That's an API action you're performing. For that API action to be performed, the backend needs to process that API action. So when Angela goes to WhatsApp and she's trying to upload a picture on her status, what is that? That's an API request she is performing. So what happens? For that request to be processed, the backend needs to process it. How does the backend process it? Through the API. So the API would handle every request from the front end. The API gets every request from the front end and then sends that request to what? To the backend logic, that's the backend application code, so the backend application code can process it. That's what happens. That's what happens. This is just simply what happens. So without an API, there is no way your request from the front end will be sent to the back end to be processed. And that means you might be trying to perform something and nothing is happening. Why? Because there is no API available to handle that request. That's simply what happens, right? So the API is not processing the request. No, Lewis. The API is getting the request that you are trying to perform and sending it to what? To the business logic, to the backend code, right? You process that request. And when that request succeeds or fails, the backend code sends that message to the API, and the API now delivers that message back to the front end to you. That's why sometimes you're trying to do something and it says, sorry, your request was not processed. That means that The backend API has taken your request. The API has taken your request that you're trying to perform, right, to the backend, and the backend has tried processing it, and for some reason it failed, right? So it does what? It sends a failure message, right, back to the API, and the API delivers that message back to you on the front end. So the only way you can process a request and receive a response when you're dealing with an application is through the front end. That's the only layer that you have access to, Angela. But where does the request get processed? In the backend. Right? All right. I know that this is more technical, so I'll give you guys room to answer your question. Now, it's already 9:49. All right, go ahead, Lewis. What's your question?
So my question is stupid, but my question is, okay, if we push requests to the back end from the front end to the back end, let's say a part of the back end component, let's say something was wrong with the database.
Yeah, it's not going to be processed.
But the business logic and the back end logic is
We'll get to what the database does. Actually, we're still here. I'm still to get here. We're still here.
okay.
Yeah, that's a very good question, brother.
All right.
We'll start the level of the API. I just want you guys to understand what the API does. So the API acts as a servant. The API gets requests from the front end to the back end for the request to be processed, and it gets the response back to the front end. Right, Kelly? That's simply what an API is. An API stands for Application Programming Interface. Let's write that down. The API an application without the backend is a dead application. This is where end users' requests are processed and where data could be potentially stored. Okay. Now, let's talk about what? We're talking about the API. What does the API do? API stands for Application Programming Interface. Okay. This acts as a servant. That means the API takes user requests from the front end, and provides it to the back end, code for processing. After processing, it provides the response, which could be a failure or success, back to the end user on the front end. That's just simply what an API does. An API gets end users' requests. So for example, WhatsApp, Angela, right? I want to focus on something that you guys are familiar with. WhatsApp. There are so many API actions you guys try performing on WhatsApp. For example, Lewis is trying to send a message to his brother. So Lewis is on WhatsApp, he's typing, and then later he wants to hit send. Right, Lewis? So at that time when you're hitting send, to the time when the message actually shows that it has been sent, right? What happens, Lewis? The API takes out your request, right, from the front end to the backend application code that handles sending of messages, and that backend application code processes the sending of that message, and even if it's fail or success, right, it sends the response back to the API, and the API sends the response back to you. That's why Lewis, you sometimes you send a message, it will show you that it failed, or it will show that it went. Right? So what has happened is just an entire process of the API getting that your request, sending into the backend code to process the request, and then depending on the result, be it successful or failed, right? It sends that result back to the API, and the API delivers that response back to you through the front end. Is that clear, brother? Yeah. Yeah. That's just simply what happens. We use applications every day. We use applications every day. It's good that we understand how these applications work. You know, before some people came to class today, some people even thought that WhatsApp that they have installed on their phone, the WhatsApp, that WhatsApp they've installed is actually the application they've installed on their phone. No, it's a mobile app client. That's what you're using to access the front end of WhatsApp. It's not the WhatsApp application itself. No, it's a mobile app client. It is through that mobile app client that you are able to access that front end of WhatsApp. That front end of WhatsApp does not live inside your phone. It does not. Angela, that's why when there is no internet, you cannot use WhatsApp, right? You cannot. Why? Because you need to access it over the internet. Through the mobile app client, you need to access the front end over the internet. Yeah. Go ahead, Mr. Divine. What's your question?
Yeah, can some applications function without internet? And in that case, does it mean that there's no back end? What I'm asking, consider a case like a calculator app, an app that's a calculator. You can use it without internet.
Yeah. In that situation, the way the logic has been built, when you're installing it on your phone, you're installing it with the entire logic. Yeah. But you realize that there are some other features that will come in when you actually have internet, because you might have to call the application itself. But yeah, in such a scenario where, you know, the application is working without internet, it's because when you are installing the application on that your device, right, you are installing even the executables, like everything about the application, you're actually installing it. You're not just installing the client. It's not the client you're installing. You're actually having an entire application with its code and everything installed on your phone. Yeah. So when you're doing things, it's actually executing because the code lives in the phone. Yeah. All right. That's a good question. I like that. So guys, that's pretty much what the API is. So there are two types of APIs in IT that you mostly hear about. Hear about REST APIs and WebSocket API. So when software developers are developing an application, they'll understand, Angela, they'll have to make a decision. What kind of API will work for this our application, depending on the kind of application. Does that make sense? Should we use a REST API? Should we use a WebSocket API? What kind of API should we use? They will make the decision. Remember, Angela, I'm just making you guys to understand these concepts, okay? This is more of a theory class. I just want you guys to be aware of how applications work. That is my goal. So please, nobody should feel like, oh, this is what you'll be doing. No, I just want you to be comfortable with some IT technologies. All right, now let's go to the backend logic. So, Mr. Divine, as we've seen, right, the backend logic is the center of the functioning of the application. Does that make sense? So, you see, Emmanuel, that's why I told you the backend developers do more work, brother, because the backend developers develop the API as well as the backend logic. Now, look at something. Look at something, Angela. For example, WhatsApp, right? WhatsApp has different functionalities. Is that true, Angela? WhatsApp has different functionalities, right? The first functionality for WhatsApp is what? The status functionality, right? So WhatsApp has a status functionality. Apart from that, WhatsApp has what? The messaging functionality. Apart from that, what else does WhatsApp have, Angela? WhatsApp has the voice call functionality. These are all different functionalities. Lewis, brother, the reason why these different functionalities work is because they have their back-end code. So anytime you are using this function, anytime you are trying to use that functionality, what are you doing, Lewis? You are trying to execute the back-end logic that processes that functionality. So developers will develop the back-end code for all functionality, Emmanuel. Right? So the messaging functionality, the reason why it works is because what? There is a back-end logic handling the messaging functionality. The status functionality, why does it work? It works because there is a back-end logic handling what? The status functionality. The voice call functionality, the reason why you're able to call on WhatsApp is because there is what? There is a business logic handling what? Handling that voice call functionality. So when you click on call from the front end, what have you just done? You are telling the API that, hey API, please help me handle this request. So the API takes that your request, sends it to what? Sends it to the back-end logic for voice call, right? So that it can process your request. That's what happens. So guys, so in IT, right? The front-end developers develop the front end of the application. Then, Angela, you have what? Developers. So what we just explained here, the back-end developers will be the ones to develop the back-end code. So these guys, they are very intelligent because they actually write the code. So they will either be proficient in programming languages like Java, they'll be proficient in programming languages like what? They might be using Java for back-end, they might be using Python for back-end, they might be using C#, they might be using C++, they might be using Golang for backend. It all depends on what programming language of choice they have decided to make use of. Does that make sense, Mr. Divine? So the company decides, right, on what programming language they want to use for the application, right? So a backend developer develops what? The backend of an application, right? They want to develop the business logic. So, Angela, when you go to WhatsApp and you're able to upload a picture on your status and the picture is there for 24 hours and it expires, it is as a result of the back-end code that they have written. They have written the code. And the code knows that, okay, when the request comes in for status to be uploaded, okay, maybe the code checks the size of that status. Remember, you guys know that maybe if you're trying to upload something for more than 1 minute, it does not go, right? The code has been written in such a way that you can validate that. Then the code knows that, okay, that picture or that video will stay on that status for 24 hours, and after that, it terminates it. That's someone that has developed the code for doing that. So maybe he has actually written the Java code for doing that. Right? So that is what a backend developer does. He loves programming. He understands what the business wants, and he develops the code to fulfill that business requirement. Right? So maybe a stakeholder says, a product owner says, hey, this is what I want. The business wants this. We want the application to do this, do that, do that. Okay. The guy now goes, right, develops the code, right, that will actually fulfill the requirement of the business. That's simply what the backend developer does. So when a request comes in through the front end, the API takes that request to the backend. Now, when the backend receives the request, okay, the backend logic, the backend code will process the request. And there are different ways the backend logic will process the request, depending on the kind of request. Angela, there are some requests that the backend logic might need to contact the database. Now I'm coming to answer your question, Lewis. Right? There are certain requests that the backend logic will have to handle connecting to a database and maybe storing some information or getting some information from the database. So what is a database, Angela? A database is where data is stored, application data is stored. Okay, let's write that down. A database, okay, a database stores application data. Okay, so a database stores application data, okay, in an organized manner. That's just simply what a database does. A database stores application data in an organized manner. Now, let me give you guys an example of a scenario where the backend logic might need to contact the database. Let me look here, brother. If all of you guys go to our school website, so that our school application is being served through a website. So you access the front end through a website. So the school application is being served through a website. So you access that application through the website. So the front end is delivered through a website, right? So look here. If you want to be part of Zashi, you have to sign up. You have to sign up, right, Lewis? So you have to put your first name, your last name, your email, your password, address, and phone number. Now look at what happens, brother. Angela, when you fill that information, when you click on sign up, that is you performing what? That is you performing an API request through the front end. Is that true? Good. Now what happens is that the backend API for the school application gets your sign up request, right? It sees it as a post request. So the backend API is that your request that you're trying to sign up, and what does it do? It gives it to the backend logic that will handle that request, right? So the backend logic takes that request now, sees that, oh, okay, this person is trying to sign up, and what does it do? It will connect to the database and it will create a profile for you. Does that make sense, Angela? It will create what? A profile for you, right? So it goes to the database, stores your first name, last name, email, and password. It creates a profile for you. And now, because you have signed up, you can now be able to log in. So when you are trying to log in, what happens? That is an API request you perform. So what happens? The API receives that your login request. It takes those credentials that you put. It gives it the backend logic, and the backend logic connects to the database to validate if those credentials actually exist and you're who you say you are. And if you're who you say you are, it will allow you to log in, or it will say that login failed. Maybe password or username not correct. So that's just simply what happens. That's simply what happens. So if you're trying to sign up to an application, for example, that might be a scenario where the business logic will have to do some validation. So, for example, Emmanuel is trying to sign up to an application. Emmanuel on the front end fills his first name, last name, email address, and a password that he wants to be using when he wants to access the site. So when Emmanuel does that, he hits on sign up. The API now gets triggered. The API gets that request. All the details you provided, the API gets the request, and the API sends that to what? To the business logic that handles that request for sign up. The business logic takes your first name, last name, email address, and password. It does what? To process that request, it has to connect to the database. It connects to the database and creates a profile for Emmanuel, right? And now, when it's done, it sends a response through the API saying that maybe a profile has been created for you or something. It will send an information. It might even send an email. It all depends on the way it has been programmed, right? Now, when Emmanuel receives that request, when Emmanuel receives that, he knows that okay, his profile has been created. Now Emmanuel might want to log in, sign in, right? So Emmanuel goes to sign in, puts the email address that he used or the password that he signed up with. And what happens again? He clicks on login, that still triggers the API. The API gets Emmanuel's sign-in information, email and password. And before Emmanuel is allowed to sign in, the back-end logic needs to process that and validate that. So there'll be a back-end logic processing what? Sign-in requests. So the back-end logic takes that request, right? It connects to the database again, validates if the information Emmanuel provided is actually what is in the database. If it was in the database, okay, it validates it and allows Emmanuel to sign in. If it's not, what happens? It sends a failure message through the API to the front end, and Emmanuel sees it and knows that maybe he made a mistake with his username or password, so Emmanuel will be allowed to log in again. That's simply what happens. That's how it works. That's how, requests from front end get sent to the back end to be processed. That's how it works. That's how it works. That's how it works. Oh my God. Am I overdoing? Am I doing too much? Am I going at a good pace? Look, I've spent about just 30 minutes, almost an hour explaining just this. Because it's important. You cannot come to do IT and you don't even know how applications work. What kind of IT are you trying to do? You don't know what the code is, you don't know what the software is, but you've done IT. And you're walking around the place, I've done IT. No, you have to understand this is important. Just know it. At the back of your mind, just know it. Oh yeah, an application has a front end, it has a back end. The back end is what processes requests. The back end has the API, the business logic, the database, and then yeah, the front end has the front end is pretty much where users make their requests. And every request that is made on the front end must be processed on the back end. And what sends the request to the back end is the back end API. All right, I'll end here for today. It's 10 minutes past 10. I'm sorry that I went above time. Please forgive me. I'll get your question. Let's watch your question, right? All right. Let me take his question. I'll just answer questions now, then I'll drop. And then tomorrow, we've understood this, so tomorrow we'll take a look at the software development life cycle. All right, take a look at the software development life cycle. We'll take a look at the different software delivery approaches, agile, waterfall, and then we'll talk about DevOps. We'll see how applications get built. Talk about DevOps, like how applications get built and deployed. Talk about that. And then we'll continue again. All right, please go ahead, brother. What's your question?
So, let's say we have a scenario where the business logic is okay, all the code that is built and the database is okay. So from the time when end users, let's say they want to post a status on WhatsApp, is there any point where I don't know the embodiment of what the API really is, if it's actually a code, but it's like a
An API is the code.
yeah, it's a code, yeah. Is there a point where an API ever breaks?
Yes. Yes,
And
that's when you go. There are times, for example, there is something called throttling at the level of the API. I'm not supposed to be saying this, but yeah, there's something called throttling. A throttle just simply means that the API has reached amount of requests you can process at that same time. So any other request will fail. There are people who have experienced that sometimes when using applications. You're trying to do something, and maybe because of the amount of requests hitting the application API, right?
at the same time, yeah.
Yeah, it will stop your request. Your request will throttle, so that the other ones can be processed before yours can be taken in. Yeah.
Thank you.
Yeah, and even when the developers are making changes as they're deploying and they're making changes, they could make a mistake on the API, maybe during deployments, and they might have to fix it back. Have you guys not realized there are times when WhatsApp has been down? There's a time WhatsApp was down for a whole day. Can you guys remember that? You could not do anything on WhatsApp because it was down. There are scenarios where Facebook has been down. It could be because maybe there was an API issue. There was something wrong with the back end, and they were trying to figure it out. Right? So they will just simply post a message on their page. Hey, WhatsApp is down. Right? They'll tell customers, hey, WhatsApp is currently down. And we're working on it, and they'll give an estimated time that the application will come back up. Those are good questions, Lewis. All right, please. I just want to emphasize on you guys being here. You guys should just keep learning. Even if it gets too difficult, just keep learning. I believe that people came and they shared their testimonies. And one of the ladies who shared her testimonies in the class last week, she has just gotten a new job. She just got a new job today. Before we came to class, she called me and told me she has gotten a new job offer. And now she has like 4 jobs. So Is it that the lady is too smart? No, it's not that she's too smart, but she has the willingness to learn. Like she stayed there to the end, right? And that's where you see the benefit. Some people just come here and they're like, that thing is too difficult, and they leave. Then just go continue, stressing themselves with what they are doing. Do not give up. That is the motto. Don't give up. I don't expect you to understand this the same day. No. Right, Mr. Divan? You might have to take your time. Go through the record again, once, twice. Then it makes sense. But you cannot force somebody to. You can only advise and motivate people to. I've had classes where there are about 100 students, and then after like 4 weeks, they drop maybe like 20%. Yeah. And that's what makes it good, right? Because if it was so easy, everybody would have been doing it. Everybody would have been making the money. So it's not all about it's not all about just being present. It's all about telling yourself that even if it gets difficult, I'll not give up. I'll keep trying. And trust me, those who are going to stay to the end, they'll see the benefits come January and February. Yeah. And there's some people give up, then you guys tell the channel, maybe you will give up. You see that they post that, hey, this lady just got a job, this lady in your class just got a job. You're like, wow, that person who was in class got a job. Maybe you are already giving up 4 months ago. So just keep learning. Just keep learning. Thank you guys for being part of the class today. I don't see any hands up. I'll give you guys access to the drive. But this video I made is free. You can share it to anybody, your loved ones, anyone that wants to understand how front end and back end works. Tomorrow you can invite people to join the class as well. I'll send the link. You can share that link with anyone to join. Then moving forward from next week, all our classes will be locked. So let's just give these free lectures. Even the Cloud 101 link, you can share to anybody who wants to understand what cloud is. Thank you guys. Thank you guys for being part of the class. I was very excited teaching you guys Software 101 today. The aspect of the components of an application software is very interesting to really see how it works, understand how it works. Some of you guys have to go through the records again. I'll see you guys tomorrow, 10:30 a.m. It's just going to be a 1 hour, 30 minutes class. I'll try to go through the rest. I'll go through fast, and then we'll get to DevOps now. I'll slow down and explain certain things to you guys. Then on Monday, we're going to start AWS. So I think that is it. For those of you guys who just started, don't forget, please reach out to Kevin Juris on Slack. Reach out to Kevin Juris on Slack. Reach out to Azimi Glenn, right? If you're unable to get to me, and they're going to make sure that you have what you need. Hey, Jenny, how are you? You didn't ask me any questions today.
I'm fine. I want to ask that, are we doing Software 101 again? Like, is this a continuation of this tomorrow?
We just started, yeah. So, yeah.
Okay.
Are you
Okay,
Are
thank
you
you.
serious because you're not going to join? You know all of this already?
No, I don't know anything. I'm learning.
All
But I
right.
just wanted to know. All right, thank you.
Thank you guys for coming. So tomorrow we'll meet and we'll continue with Software 101. Thank you guys. Good night, everybody. Good night. Good night. Good night. Did you guys enjoy the class? It's not getting real yet, Anita. Like I said, remember, I just want you guys to learn. Normally, I'm not supposed to teach this. I'm not supposed
Thank you,
to.
Prof.
You're welcome. I'm not supposed to teach.
Thank you, Prof.
Thank you, Prof.
Yeah, I'm teaching this so you guys can learn. Remember that, right? I'm not supposed to teach this. This is not supposed to be part of the cloud lecture. I'm doing this so that you guys can learn. I cannot just come and start teaching you people cloud and things where you don't understand basics of IT. Right?
It's
Right?
because we're a lucky set.
Amen. I mean, yeah, I always look at to all the students, please. So nobody should feel like, what is this guy even teaching us? Is this important? Please. I just did so that you guys can at least have an understanding of Software 101 and how it works. Yeah. All right. Thank you, Mr. Divan.
Thank you.
Night.
Thank you very much, Prof.
Thank you, guys. Thank you. Yeah.